Hello everyone and welcome the second lecture of digital electronics. So let's begin. By the end of this lecture, you guys will be able to describe what is digital signal and what is digital circuits. Now let's move into the next slide. From this slide, we are getting know that we would like to learn plenty of things from this lecture, such as digital signal and examples, digital signals graphical representation, digital circuits or digital systems along with examples, and so on. Let's move into the next slide. From this slide, we came to know what is digital signal as well as the example of this parameter. So let's begin with the digital signals definition. A digital signal is defined as the signal which has only a finite number of distinct values. Digital signals are not continuous signals. In the digital electronic calculator, the input is given with the help of switches. This input is converted into electrical signal, which have two discrete values or levels. One of these may be called low level and another one is called high level. The signal will always be one of the two levels. This type of signal is called digital signal. Now come to the example section. There are several examples of the digital signal, such as binary signal, octal signal, and hexadecimal signal, etc. Let's move into the next slide. From this slide, you guys will get the information about how digital signals looks alike, or you can say the graphical representation of digital signal. Like analog signals, like the slide of analog signals graphical representation, there is also a two-axis system. One is x-axis and another one is y-axis. And if you guys have a close look in this figure, then you can notice there is no name in x-axis as well as in the y-axis, but there is a specific value indication in x-axis and also in y-axis. As we know from digital signal definition slide, that digital signal is finite, so that's why there is a specific value indication in x-axis as well as in y-axis. So that's it from this slide. Now move into the next slide. From this slide, we came to know what is digital circuits and the examples of these circuits. Well, let's begin with the definition. The circuits that process the digital signals are called as digital circuits. It is sometimes also called, or it is sometimes also known as digital systems. Now come to the example section. There are several examples of digital systems, such as registers, flip-flop, counters, microprocessors. So let's move into the next slide. From this slide, we came to know some of the advantages of digital circuits or digital systems, such as more accuracy, more versatility, less distortion, easy communicate, possible storage of information. From this slide, we can conclude a comparison in between analog signal as well as digital signal. So let's begin. Number one states that analog signal has infinite values, whereas digital signal has a finite number of values. Next one, analog signal has a continuous nature, digital signal has a discrete nature. Well, next one, analog signal is generated by transducers and signal generators. But in case of digital signal, which is generated by analog to digital converter, and which is in short we can call it ADC. And the last comparison, example of analog signal such as sine wave, triangular waves, whereas the example of digital signal is binary signal. Let's move into the next slide. You will get the information in the next lecture is digital number system as well as decimal number system. So let's move into the next slide. So thank you so much for your attention. That's all for today. See you guys in the next slide. Thank you.